Hello guys, let's solve another Leetcode problem, linked list cycle. We are solving the blind 75 list. We already solved reverse the linked list inside this linked list section. And we are going into the detect cycle in a linked list. This problem is linked list cycle Leetcode 141. It's an easy problem because you can solve it pretty easily if you store the data what you have seen. So let's see the problem. So we are given a head of a linked list, and the linked list start with, for example, for this example one, the linked list start with 3, right? So 3, 2, 0, and -4. What we want to do, we want to figure out if there is any cycle inside this linked list. So main difference is that if it's a single linked list, the last node should point to a none or a null pointer. But if there is any cycle, basically it points to any of the previously seen node, right? So let's solve it pretty easily. So since it's an easy problem, and if you just store the data node what you have already seen, you can solve it pretty easily with order n runtime and order n space, which is a good algorithm, at least to get started, right? So we'll get started with that one and then try to find out how we can optimize this one, right? So to get started, if your head is none, that means if it's null, or head.next, that means any of them is null, you can basically return false, right? Because there is no cycle inside this linked list. And so what is the next step? So you basically keep track of all the nodes, what you have already seen. So there is 2 ways to do it in Python. You can use some sort of hash map or dictionary structure. You can either declare this scene as a dictionary where you will need key value pair, but another option actually you can just declare it as an set, because set also the implementation of dictionary inside the Python. Basically, you just need to know actually, did you see that node before? So we declare this one, and then what we want to do, we want to check actually while head basically not equal to is not none, right? And so if you have seen this head before, if head is seen, you basically want to return true because you have seen that node before. Otherwise, you will go through this linked list with head.next. And before that, you just store that node into your scene set. And finally, when you are outside of this while loop, basically you can return false because that means there is no cycle inside this list. So let's see if it works. Then actually we will go into the detail what are the runtime complexity we are using, and then we can see how we can improve it, right? So it's accepted 48 milliseconds. So that's good. So let's go back to the description. So what is the main thing what we are doing, right? So we have a while loop, and this while loop actually makes sure it's go through the whole list unless you find a cycle before than that. So it will be order n runtime complexity. You are storing all the node in a set, and then actually you are checking it if it's in the set or not. So which in Python it can do order 1. So basically you need order of n space. So it's a pretty efficient algorithm with order n runtime, and from the runtime perspective, from the space perspective, you are actually using this data structure to store the value, so order n space. So definitely talk to your interviewer, figure out actually if it's acceptable. If it's not acceptable, then think about how we can do this algorithm without using these extra storage, right? So we can comment out this part of the code and then let's see if we can go into the part where we can do without using extra storage. So let's draw this one. So we'll draw this thing here. So we have 3 and 2. So we have 3 and then we have 2, second node, and then 0, then -4. And basically these -4 is point to this 2 here, right? So and we have to figure out if there is any cycle or not, right? So the other way to solve this problem, you can keep track of 2 pointer. One pointer is like a fast pointer and another one is slow pointer, or fast or second pointer, right? So basically what you do, if your fast pointer is here, and then take another one like red. So this is your slow pointer, right? So in each step, you basically want to update your slow pointer one at a time. So you point to here and then here. So in each step, you go one. But for the case of fast pointer, what you want to do, you want to actually go 2 pointer. So you skip one of them, right? So if you skip one of them, you see actually next time it will point to 0 to -4. This is 1. And then finally it will again point to this guy, right? When you update your fast pointer. So the mathematical reasoning behind this algorithm is that if you are going through one pointer slow one at a time, and if you are going through the fast pointer 2 at a time, definitely if there is any cycle, the fast pointer will hit your slow pointer one time, right? So that's the idea of solving this problem. But if anytime if you hit the none pointer, that means there is no cycle, right? So to do it, you can have 2 pointer, right? Slow and fast. Both are starting with head. And if you are checking if your fast is not none and fast dot next is not none. Then you are updating your fast pointer to place, update your slow pointer to the next node. And if your fast is slow, that means both of them are point to the same node, then you will return true. That means you have seen a cycle or detect a cycle. And if you're outside of this loop, that means you didn't find any cycle. So what we are doing actually, we are going through the loop and then you check it, the fast loop actually going 2 node at a time. So basically you are going through the loop actually skip 1 node at a time. So in the worst case, you will go through the whole linked list twice. But for the case of slow, you are just going to 1 node at a time. So definitely a order n algorithm, and you are only storing slow and fast. And so this is actually constant space, right? So let's run this code. And if it works, then actually we will talk about a little bit more about what are the main advantage using this one to the old one, right? So yeah, okay, it got accepted. So the main difference between the commented code and new code is that in the commented code, you have a scene set data structure, which in the worst case might be order of n, right? And here you are storing extra one, only the fast variable, right? So definitely both the algorithm run in order n time, but this new algorithm actually solve this problem is constant space, whereas the old algorithm was actually order n space. Yeah, that's all for now. Thanks for watching. I will see you in the next Leetcode video.